Hello, and welcome to AI-driven part sourcing to optimize supply chain efficiency. I'm Bob Treblecock. I'm the editor of Supply Chain Management Review and an editorial director at Peerless Media, and I'll be your moderator for this event, which is being brought to you by our friends at Dassault Systems. Joining me today are Rob Donath, Matthew Modelonde, and Ken Barrett. Rob is the NETVIBES Senior Industry Process Consultant with Dassault Systems. Matthew is a partner with Avancore. And Ken is the NETVIBES Senior Sales Expert with Dassault Systems. All three are experienced supply chain professionals who I know you're going to want to hear from. Before we get started, a few housekeeping items. Now, if you haven't done so already, I'd like to remind you that attendees are invited to download today's presentation. Just click on the resource icon on your screen. And when we get to the end of the presentation, we're going to have a URL where you can download a special ebook from Dassault Systems. This is an interactive event. If you have a question for Rob, Matthew, and Ken, feel free to submit it as you listen to the webcast. If we don't get to all of your questions, we'll forward them to our presenters later, and they can get back to you by email. Now to today's webcast. Procurement professionals are in a world of hurt. The job is no longer about buying at the best price. They're facing supply chain disruptions, increasing product complexity, and proliferating parts and duplicates. They need a smarter solution. Using the power of artificial intelligence and 3D similarity, new technology can help to optimize sourcing and standardize components for significant time and cost savings. Today, Rob, Matthew, and Ken are going to explore how AI for parts sourcing can help procurement professionals make intelligent make or buy decisions and optimize supply chains. So Ken, let's start with you. Welcome, and without further ado, the microphone is yours.
Thanks, Bob. So when we as a company look at AI for sourcing savings, we've uncovered over the years typical challenges that customers are facing. The number one challenge is an unstructured execution system. So either through organic growth, through mergers and acquisitions, companies are growing, and data is really everywhere. I know the new term now is data swamp, and getting access to that data is critical, especially when making a part decision or sourcing decision on parts. The second challenge is a lengthy reuse process for parts. So one, trying to find the part, but two, that process to find that part taking so long, a designer or engineer typically thinks it's quicker for them to build it than it is to find it, and not to mention all the associated documentation that needs to be associated with that part. The third challenge is around cross-program standardization. So programs running independently when there's part and engineering efficiencies that can be gained, but because they're running in silos, people don't have access, or engineers don't have access to that data and that information that's needed to make a reuse decision. And the third is weak procurement performance, not in the sense of the procurement being weak from a job-related perspective, but not having the information they need to make a sourcing decision. So not being able to take the information that's coming from ERP, inventory, and marrying that data with the information that's typically in a PLM or PDM system, so you have a view of that part with the data. So these are four of the biggest challenges that we are seeing in the industry, in multiple industries today. And our goals around sourcing standardization is to give our customers a comprehensive view of the parts they're supplied, no matter the size of the company, the location of the data, the format of the data, to quickly identify cost savings, and a lot of times customers are finding cost savings immediately. So we're looking at part price inconsistencies, identifying alternate parts for better price, better quality, especially given our recent pandemic year. Suppliers and trying to find the right parts or alternate parts has been very difficult to avoid plant closures or part shortages. Accessing engineering information for part to be supplied. So when we say that in engineering information, we're talking about all that associated information. If you have information on material compliance, ITAR, export control, FEA studies, anything that would need to be associated with that part to make an informed decision. And then last, identifying the best suppliers for specific manufacturing process materials. So what suppliers am I working with that have provided us a high quality part and can meet certain requirements that are specific. So if you are looking for a particular fastener or bolt that's been heat treated or has a special coating, how can I find that data attribute that's assigned to that part? And then how can we help in these areas? So what we've uncovered and what we validated with some of our external sources like Aberdeen is about 45% of an engineer's time is spent searching for or recreating a part. And that's one of two main reasons. One, again, an engineer could feel that he or she could build it faster than they can find it because maybe they're not able to find a part based upon a naming convention or the information being in a different CAD system. Or two, they don't care about the downstream effects on cost. Their thought is, I've got to get this job done, and I can't spend all my time finding a part. And what they don't understand is what we talked about here is that the carrying cost of introducing a new part, not to mention introducing risk to a design, but is in between $4,500 and $23,000. And what we hear it's even higher in aerospace, but that new part introduction, is a challenge to get the downstream engineering design folks to understand that there is an impact or cost impact related to new part introduction. And then the last by Arthur D. Little Research Company, 80% of the work done in engineering department is identical work that's been done similar. And we've seen that time and time again. One of our bigger partners, our customers with Parker Hannifin, they were introducing a new model of one of their components, and they found that 80% of that component had a reuse opportunity. So they were able to leverage the data and information that they had created prior and really only focusing on that 20% of new parts that were being introduced, and we're able to deliver the part to time to market a lot quicker, leverage the existing inventory, and reduce costs fairly significantly on this new part launch. So this is just really some studies that we wanted to share with you that our findings have been validated by independent studies as well. So when we look at some of the cost savings opportunities that we focus in on, the number one is increased operational efficiency. So reduced search time for your engineers, designers, manufacturing folks. Quicker go-to-market is some of the results there, and as well as kind of capturing institutional knowledge. So so some people know they've been with the company a long time how to create and find a part quicker, and that's typically trapped on somebody's desktop. How do we gain that access to that information? Reuse, don't just redesign. So the challenge really there is basically that data being scattered everywhere and finding it. So we have and Rob will talk about this later, a unique way that we're searching on the geometrical shape of a product. So we're not looking, or a part, so we're not looking for a naming convention, a CAD, or we're looking at the shape. So we can run those comparisons very quickly and bring that information back regardless of the format or the CAD it was created in. Optimize cross-division program part reuse, and then identify part price supplier variability costs. So the unique thing here, especially for procurement and supply chain, is the ability to pull that information from ERP or inventory systems or supply chain systems and marry it with the PLM data. So a lot of times we're dealing with procurement, and they understand that there's a part duplication problem, and engineers are telling them, hey, you know what, I've developed or designed this new part for a reason. And what we're finding is we can give procurement the information they need to go back to that engineer and saying, here are these parts that you've introduced. They're 100% identical from a geometrical shape perspective, but I'm paying drastically different costs. And we had a situation at Honda that we worked with them on where they had over 100 of the exact same identical bolt. And it wasn't until procurement came back to me and showed them the information that engineering said, yeah, we got a problem and we need to address it. So typically when I show this slide to executives, the first question they do ask me is, give me an example of one of these areas. So it kind of led us into some real life examples on operational efficiency. Across the board, we're being told by our customers that we've reduced the search time on parts from hours to minutes. One use case was a part shortage. This was done on the manufacturing plant floor where the parts were short, and they were able to search one part system and find an identical part at a different plant, have it shipped over, and they avoided a plant closure. An example on the reuse redesign, another supplier shared how they eliminated 50% of their design cycle time in reusing approved components. Cross-divisional program reuse. This is an interesting use case because it was a supplier that was buying parts internally as well. But two divisions, we found both these parts were 100% identical as a geometrically shaped perspective, and they were buying these part prices at dramatically different prices, at a 200% increase on one over the other, that they were able to go back to another supplier and negotiate a better part price and lowered their, I think it was a 56% annual savings on that commodity part that they were looking at. And the last around supplier variability, this is a project with a supplier that looked back at their spend on parts in a given year. We indexed all the new parts that were created, compared them against their database, and found a number of parts that should have been reused that weren't. And they did a quick estimate based upon the spend and saw about a 36% annual savings that they could have recognized if they had had a better, we call it NP, new part introduction process or policy or process around introducing new parts to the system. So what we find is it's an educational thing, and a lot of times people just don't understand where these efficiencies could be drawn out. So what we've done is we've partnered with a company called Avancore who specializes in just that. And I'll introduce Matthew to kind of talk about the benefits that Avancore brings to the table once we identify this opportunity, how we can save companies money.
Thank you very much, Ken, for this very, very clear and sharp introduction. Actually, before jumping into the demonstration from Rob, I would like to give you a few hints about the partnership that we built together with Dassault Systèmes and the reason of being of this partnership. So we, Avancore, we are a consulting company. We are specialized in industrial competitiveness, and we support our clients, basically large industrial groups, in making more competitive products. That's what we do. And you guys know that Dassault Systèmes, on the other hand, is a tech provider that is providing some high-end solutions, also aiming at improving their clients' competitiveness. So if you combine our knowledge of the industry sector, the stakes, the different ambitions of everyone around the table, together with the solutions from Dassault Systèmes, there is definitely room to bring value to our customers. So that's the reason why we built this partnership together with Dassault Systèmes. Just 1 minute regarding Avancore, who we are. So we've been created more than 10 years ago. We have something around 100 consultants spread worldwide between 4 offices in the US, in Germany, in France, and in China. And we are working pretty much in any types of industries. Actually, just like Dassault Systèmes, we are sharing the same clients. We've been working on more than 600 projects over the last 10 years. That is bringing quite some substantial value to the table when it brings to these kinds of projects. So now coming back to the types of potentials that could be generated by the tools developed by NETVIBES that you will have a demonstration in a couple of minutes. Based on our knowledge and based on the different projects that we had the occasion to lead with many clients over the last few years, we've been able to generate something between 5 and 15% of direct cost savings. This is quite substantial, and this is mostly leveraging, I would say, 6 or 7 different types of levers that are directly enabled by NETVIBES. The first one, I think you will see it later on when you will enter into the tool. The first one is the enablement of negotiations, levels, kind of negotiations that a human brain would not have been able to identify by himself without having such a level of analysis, leveraging the artificial intelligence, the ability to compare prices, to identify some cost ratios that make sense, and to provide the sourcing leaders with a very nice lever to go and negotiate to the client. So that to the supplier, sorry. So that's the first lever. The second one is what we call the interchangeability. So that this is the ability to identify some alternative parts that is already existing within your products that could replace others that are more expensive. So the tool will enable you to identify similar parts just to replace that are fit for functions and cheaper. So that's what we call the interchangeability. The third one is the part number change, which is quite close to the interchangeability, but this is not the exact similar parts that might require some validation, technical validation, in order to actually generate potential savings. Besides that, you have some additional levers that are interesting to activate thanks to NETVIBES. The first one is the one that we call the price inconsistencies, which is basically providing to the sourcing team some interesting information when they are buying the same parts, but with different prices. It happens quite often, actually, when you are global industrial groups, that you have units in the US that is buying one part at 10, and another unit that is buying the exact same parts but at 12. And thanks to this tool, it enables you to identify, to spot these kind of issues and try and save the money that you could save between these two values. Supplier allocation, for sure, it helps you identify the most competitive suppliers and hence generate some substantial savings. And the last one is sourcing. You will see that there is a very nice ability to identify some alternative suppliers. There is already a database with qualified suppliers that could be competitive and alternative to the one you already have in your panel. So all in all, thanks to the NETVIBES sourcing and standardization tool, you should be able to generate 5 to 15% direct savings. Well, actually, this is not that easy. So this is the reason why we build a partnership with Dassault Systèmes, because we strongly believe that doing it by yourself is complicated. You need the support from experts, just like Evencore, in order to make sure that you can generate as much value as you could from this tool. Here, we've built a typical approach, which is, I would say, a few months length to generate some savings that you can measure in your P&L. Very first step is what we call the framing, which aims at identifying within your portfolio of spend which commodity should be the best targets for such a tool. Whether it is because of the annual spend, the type of commodity, the availability of CAD drawings. So all of that will take a couple of weeks to make sure that we are targeting the right commodities to perform such a project. Then we would enter into what we call the value proof through a pilot. So we would select together the right pilot commodity that would be the right one to generate savings. And we perform a first value proof, meaning that we gather some preliminary set of data, a sample of your data, and we integrate that into the tool and see together how it looks like. We validate the fact that using your data, there seems to be potential, and we seem to be able to generate substantial savings. And how much? Is it 5, 10, 15, or even more than that? Once we are done with the value proof, we have confirmed with you and your team that we can generate substantial savings. we know that the commodity we have selected is the right one. No, we need to make it happen. We need to generate the value, and we're entering into the third phase. This is where we actually spot the opportunities, the changes to perform, the negotiations to perform, the interchangeability to perform, and actually generate savings into your P&L. At the end of the third step, we have together saved money to your company. But we can go further than the pilot scope that we have selected, and we will go for a global deployment afterwards for other commodities, aiming at generating much more savings. So this is the typical approach that we've built, that we have deployed with many clients so far, and that have proven its value for the last few years. Now I will let the floor to Rob, that will show you a little bit more the tool, make a demo, and tell you how it works. Rob, this is yours.
Thank you, Matthew. Yes, the applications that Matthew described in their use with their customers and helping them establish these savings values are typically wrapped around these 4 solutions that you see on your screen here. The one-part reduce application is really used to do the standardization and classification to help provide for a centralized way and improve the redesign and reuse scenario, as well as being analyze information that's coming across programs to give you cross-program value. The reuse application, one-part reuse, is used typically by the engineering staff as they're designing. So you'll standardize and optimize and classify with reduce, and then you can roll that information to reuse users, the engineering staff, so that as they're looking for parts and components for their design process, they're selecting the preferred parts based on cost, based on weight, based on supplier quality, et cetera. Being able to analyze or search for things based on classifications that have been defined through the use of the AI tools, machine learning of the reduced product. And then the next one, which is procurement intelligence, actually takes all of this information from the classification mechanisms, the CAD information from the engineering staff, and all the other information, and is augmented with your procurement information, so your purchase ordering information, so you can get costing and do analysis around vendor quality and vendor cost averages, looking for potential vendor finding alternative vendors, suppliers for parts maybe that you're running into some supply chain or quality issues for, et cetera. And this 4th solution is a way to use our cloud infrastructure to establish a preferred vendor catalog of information along with your internal parts, and can also be used to bring your suppliers' parts into your ecosystem, as it were. And we're going to show you a few of the mechanisms around there that provide the value across really all 4 of the sort of major key areas that our customers are working with and deriving to. So with that, I'd like to drop into a screen share here. We're going to do a little demonstration of each of the products and kind of walk through the basic scenarios that you might see in the use of it. So hoping for my screen to come up. And the first one I wanted to start with is that part reduce. So part reduce uses CAD model geometry and attribute information around materials and other specifications and program information, et cetera, to analyze and allow you to classify across a plethora of what we would consider universes of our data. I have a procurement universe that was created here, where it has gone and analyzed all of the parts in my ecosystem, clustered those parts based on the number of parts that are similar in shape and size, and where we can actually also then define different sort of classifications. So I'll click on this sort of linear bracket here. You can see where these were defined as a bracket, a linear bracket type. We can do a similarity review, so we can look at how similar they are to shape and size, feature functions, other types of information around here. It's almost like I'm shopping on Amazon, but I'm trying to analyze all this information to decide which one should be a preferred part or maybe set up as an alternate part here. Or perhaps we want to try and obsolete it. We're going to remove this from the cluster of managed parts and try and maybe replace it with another part that we might have in the future that would be passed off as an engineering change, et cetera. And we can add or augment additional information based on the data that you might have in your existing sources to include things like costing information and weight information and supplier quality and things like that to make the best decision-making process for setting up the classification standards and the preferred part categories or preferred parts inside of each of these categories or classifications that you may exist. Creating these clusters using the tool is actually quite fairly simple. I can create a scope or a universe here, and we can create universes that are based on different types of things. So we might be looking to organize and reduce parts out of our elimination or eliminating duplicate parts based on standards, or we may have an assembly. Maybe I'm a product manager for an assembly or a program, and I want to analyze this assembly and see if there's parts in that assembly that could be replaced but with lower costing parts or better quality parts of parts that we may already have in our system. So you can create this scope of universes, analyze your information. It uses machine algorithms to go into this data then and find it. And then once you define it, set up that these are going to be the new standards, classify that, and publish it, that information then goes back to the organization that will be using that for their design activities. And that's where the one-part reuse application comes from. So in one-part reuse, you have the ability to do searching for content. So, I might look for brackets here, and I'll do a search by text for brackets, and it's giving me, there's 33 different types of brackets, and they have different sorts. And then I can use classifications to narrow that down. So I might have categorization families as were defined. So this is where that reuse is taking advantage of what was done in the reduced product by the standards groups to determine which brackets you might want to utilize and how they could classify those and find ones that are similar and work through that information. I can, select a given bracket here, and I can see additional information around it. So it automatically describes ones that are similar in shape and size. I can see buying-related information if we choose to make that information available so that they can see, are these in stock? But as an engineering user, I may or may not have access to that buying information here based on the purchase orders that came in. I can also see things like parent-child relations, that this is the parent for that part, and that it itself has 5 children in it. We might actually have ancillary data or documentation that are available to assist in the engineer being able to see this particular part. You even have the ability as a non-engineering person through the use of this tool to get a 3D view of this part, or even do some things like measuring values inside the part, looking at, say, maybe the distance between this part of the flange and that part of the flange to get some measurements. If I'm a procurement person and I'm looking for trying to source these parts, having the ability to go in and actually see what the part looks like as I'm trying to source it can be very valuable in trying to find the right kind of supplier as well. So there's use in this case as well. Okay. From the reuse and the being able to see how it's what sort of where used, similarity, et cetera, we can start generating this information, making it available for the engineering staff, as Ken mentioned earlier, to shorten down the how do they locate content, how do they locate the right part that they need for their design aspect, and then be able to utilize a part that already exists in the system rather than going back to the users of the supply chain organization to try and source in a new part where one already exists that they could potentially reuse. The third application that I want to demonstrate is this procurement intelligence application, and this is really key for supply chain individuals, right? We want to look at, how are parts expenditures evolving over time, or what's the breakdown of my parts by vendor. I'll take a look at this overview screen where we actually see the total spend based on the indexing and understanding all of the purchase orders. So we got $7 million over 4,800 purchase orders that are referencing about 820 parts. And the quantity or the number of parts that we have purchased over time is about 500,000 from 30 different vendors in 20 different geos, and they're all being sourced into 10 different plants for 5 different product lines. Quick overview of what's going on. But I can see timelines of what are the expenses that were, the purchases by buyer or purchases by plant or by product categories that we may have defined inside of that reduce application. And these are fairly live and actionable, so they're based on how frequently we update this information. And perhaps I'm going to have a conversation with the team, or I could be using these tools to describe or talk about what have we been doing, what's happening over the organization. You can use this material information for presenting as well. These dashboards are fairly actionable that way. Or I can even switch in some of these dashboard views widgets to actually see the underlying data and the values, that the numbers that are derived to create this graphical view. So you can take advantage of these graphic widgets for this kind of information. We can narrow down on information by vendor, as I mentioned, so I can see the different suppliers. I can click on maybe a given supplier here and see information around what plants does that supplier supply parts into. What's the average cost for the parts by that supplier, et cetera. These are creating filters. Now, I can also go through the filters over here and selectively pick out filters that I might need or want to narrow down by. Maybe it's by vendor or country for the purchases coming into the various plants in that country, et cetera. So we have the ability to drill into the data, analyze the data, see it from these different types of views based on the buyer or the parts, et cetera. One of the things that I'd like to go into perhaps is that I'm looking at the overall part categories, and I'll just kind of look at this one. In this particular part type or component type, we have spent about $61,000 US, but we have a potential price to get down to of $36,000, or almost half the price, based on quantity and volumes. And if I select this particular one, I can get an idea of what was spent. I can see our spend is down over the last year or so, but timeline based on the product lines that we're using this in and the plants, and the fact that we're buying these same parts through these 4 different suppliers or 9 different buyers actually against this data. And from here, I can actually see the sort of parts that are involved in here and the potential savings of these parts for this particular group of content. So I can, from a supplier or a procurement standpoint, see what the part looks like, see what our average price is, how many purchase orders have we had. You can see that the average price was at 16, but the actual lowest price that we've been getting at it was $64 or $6.14, and the maximum we've been paying was $25. And part of that may be based on volume, part maybe location, et cetera. But I can see over time, what's been our total spends for this part, this group of parts, and then I can see the corresponding purchase orders that lets me get into the details, drill down into the details. How frequently are we buying it, and what are the different part numbers that we're buying for this particular component part or cluster of parts as described in that original part reduce section that I had showed before. And then from here, we may have a situation where we're looking at these particular parts and we can work out how we might, reduce the cost because we have a lower price, but we can then go in and start to analyze even further around this information. So here we can see that these are the parts that are inside of that cluster that we talked about, and the different parts that are similar. We can see the price against the ordered quantities, so we can see how, the more quantity, the more that we ordered, that the price, went down. The price of the parts typically went down. That's pretty averaged. the key here is that we can also make some assumptions and try and do some predictive analytics around, different parts. If we could increase the number of parts, maybe, increase the volume that we might go into. So say, if I can double the number of parts that we order, and maybe we're going to do something like realizing that if we have more holes in the part, in this case it's telling us that there's one hole in the part, but if we had to purchase another part that had more holes on it, that's probably going to take more manufacturing costs. So we can get an analysis of how that part costs might change based on those values. And so we can start to understand where any change to a part could impact the downstream costs around that line. And then we could take these sort of snapshot views around this to set up a couple of different scenarios and then overlay those to find out which vendors may be able to produce the part at a lower cost for us, or typically running as a lower cost around that, to be able to see, looking for outlying suppliers who are typically setting their prices significantly higher than others, or could potentially be a candidate for an alternate supplier if we're having delivery problems with a supplier who makes parts that are very similar to this one, and has the ability to manufacture with the same kinds of materials that this particular part type is utilizing, or things along that line. So the ability to analyze the supplier community, analyze your purchase order information, augment that on top of the CAD models and the similarity that the engineering group can provide for you through their knowledge of that information, through and analyze through this machine learning and artificial intelligence algorithms, enables you to really get a handle on where you could potentially drive long-term cost savings for the organization and improve your supply chain coordination and management. The fourth application that I wanted to demonstrate and take advantage of showing you is something called parts supply. Now, parts supply is typically also used by the engineering group. It's a catalog, a part library of over 60 million parts and components from 1,400 or so suppliers currently, where engineering staff can go in and take a look and search for a part in a given catalog or category and actually download the component part model to bring into their application. And there's other suppliers of these kinds of tools out on the web that the engineering staff use, but typically those tools don't actually give you information around the actual supplier of the part, which enables procurement to actually go back and deal directly with the manufacturer of that part. But we also have an application on top of this that's more derived for the supplier community and setting standards at the corporate level, that enables you to create your own sort of ecosystem of parts, right? So here you can define which ones of these suppliers that are in this catalog, this online catalog, do I want to make available for the engineers as preferred or approved suppliers. And that enables them, when they're going to select a part from here to download a CAD model, they're going to grab one from a supplier, or they're going to select and grab the model that they made from one that's already been approved and may already be purchased by our organization. But on top of that, we have the ability to take both those external parts from the ecosystem of the community here, which we would consider the external catalogs, and augment that with our in-house catalogs. So I can upload or link up our content from our own organization and make that available for the engineers to also select from. But that's more private. That's only available for the engineers who are part of our organization. But what we are seeing is other companies are actually requesting or asking their suppliers to make their catalogs available online through this platform, so that the OEM tier can go to their supplier community, approve the ones that are necessary, and make that available for their engineering organization to deal with through this tool. And if they actually go and select a part that doesn't belong to that approved group, there is an approval process that they would have to request access for that part, and then that would go through the normal approval process that would enable procurement and standards to decide that, yes, this particular part does make sense. We don't already have one. We feel comfortable with this supplier, and we can negotiate a reasonable price for it. So that's the basic gist of the application solutions that are utilized by our customers and with the assistance of partners like Avancore to help organizations find the kind of cost savings that we've been describing throughout this portion of the presentation. So in my screen share, so in addition to procurement and engineering, this plethora of information, this sort of 360-degree view of parts and costing and support documentation can really show value across all portions of the organization. It enables them to collaborate and work together so that things like machine tooling, when we're designing tooling to build the parts internally, we can reuse a lot of the tooling designs along that line. I've seen situations where manufacturing organizations, especially at the material management and material handling, they're bringing parts out to the assembly lines, et cetera. As they walk around, they'll see random parts just laying around on the floor and pick those up, and they bring them back into their storage warehouse locations. The tool sets can be utilized to also help them actually identify these random parts that may not have a part number or a part tag or anything associated to them, so they can return them back into inventory that much sooner without a lot of extra effort. So they can do things like 3D scanning the part and using that scan to search for the part inside of the reused product, identifying by doing some measurements of the part to try and use those measurements to determine exactly which part that might be, especially if they can also have information about the fact that that particular part has been ordered and is in use in that particular plant through the procurement and purchasing ordering information. Ken had mentioned something around institutionalizing the knowledge. A lot of organizations, especially during the COVID timeframe, and had lost a lot of very senior engineering workers who had that tribal knowledge of these are the parts that are available, and buyers who have been working with, long-term strategy with different suppliers and organizations may have gone into retirement. By pulling all this knowledge together and institutionalizing it, these visual views and easy search tools enables you to sort of create this institutionalized knowledge that you may have lost a little of tribal knowledge around as people had moved on to other locations. Okay. So I'm going to turn it over to Ken now to give you some more of these client examples, and thank you for your time.
Thanks, Rob. Yeah, I want to highlight 3 quick customer examples. I'm not going to go into all the details, but around part rationalization, the interesting thing about this supplier's use case is they actually have built out over 45 different use cases for how they have saved the company money, identifying what their challenge was, what the impact of the business was, how they solved it, and then obviously the overall value. And, with this organization, a lot of the initial conversations to how this solution got implemented actually started in supply chain procurement, went into manufacturing, and then through engineering. And in a kind of a conversation with one of the C-level executives here on the supply chain side, he said that the solution has helped create a cost-oriented mindset, thinking of how can I save money using the tool. And it was interesting to hear him say that how it transformed just people's thinking and finding out new ways to use the technology to solve problems. Now, Rob mentioned a lot on manufacturing plant floor stuff as well as supply chain and through engineering. The second use case around cross-divisional standardization, this one was interesting because there was 4 different ERP systems. I think there was 20 different sites, 2 PLM systems, and 4 different CAD systems. So multiple data formats, locations, and their feeling was we improved their reuse on visibility into these products by 80–90%, just having that ability to have that data all aggregated in a way that didn't require us to create a new system of record and convert any data, but it gave them access to the information they needed to make decisions. The last around cost rationalization, this company used the 3D geometrical shape to do two things. One, they wanted to group and cluster the parts that were similar, and then also use the ability that Rob talked about where we actually looked at quantity and part price and then establish an average on a should cost of what that part was going to cost. The supplier needed to go back to his suppliers and ask for a reduction in cost for part price because they were getting pressure from their customer. And what they were able to do is not penalize those suppliers that have been good to them over the years. They looked at the part numbers and said, here's our average, here are the people that are above the line on the average cost, here are below, and above the line I need 35%, below the line I need 20%. And they felt that it was a much fairer way to look at not only the should cost and bidding for new parts, but when they did need to go back to suppliers for part price reduction, they had that information that was ready, available to really back their the request that if they were above or below what the standard cost was. So what sets us apart? And we've talked about this a lot. We're agnostic to the CAD data, the CAD format, the PLM system, the PDM system, the database, the source of record is going to remain intact. So because we're not moving large sums of data, we can analyze extremely large data sets very, very quickly. So like when we're dealing with material compliance databases, our search time is minimal. Efficient shape search and similarity matching. So this is the key. When we can find shapes that are geometrically the same, you can add as many attributes as you want about that part to do that comparison. And as Rob said, when we do our comparison and you can set the similarity score to 100% or less, you have that, we automatically will highlight the differences as well. So when you see parts that are 95% the same, we'll let you know very quickly on what the differences are between those parts to allow you to potentially use a part that might be close enough. Again, we're staying in the system of record. We're not creating a new system of record that gets having different versions of the truth everywhere. And then lastly, the integration to the ERP and CAD, MRP, MES systems for that 360-degree view of a part, so that you can make a sourcing decision based upon the price, the quantity, available inventory, and even adding different types of information around supplier quality and things like that. And then lastly, some key takeaways. Looking at the operational efficiencies, breaking the silos, quickly. We're going to make it faster for an engineer or a designer to find a part than it is for them to create it. Making the reuse, redesign decision very simple. In the use case I talked about with one OEM and having 100 different parts in both, how do we look at that and decide which one of the 100 now that you found them? But having that ability to select a preferred or an alternate part, so when they see those 100 that are available, to know which one or two that have been selected based upon engineering or procurement standards on price or any kind of other variable you want to add. Bring that cross-divisional program reuse. It's every company. Everybody's got multiple CAD, multiple OEM, ERP, and having that ability to be agnostic to that is critical. And then again, on cross-divisional, being able to handle any kind of ITAR or export control requirements that might stop you from analyzing or looking at different parts across divisions, we take care of that as well. And then supplier variability. We're gonna allow you to analyze the suppliers, the parts they're providing for you, the prices that they're providing them to you for, and are they above or below what everybody else is, and being able to do that very quickly to make sourcing decisions or help with your supplier negotiations. So with that, I want to thank you for your time. I want to open the floor up for any questions that you might have right now for Matthew, Rob, or myself.
Well, thank you, Ken, Matthew, and Rob, and thank you all for attending. Now, we are about to do a brief Q&A, as Ken suggested, so I'd like to remind you that if you haven't done so already, please submit your questions. Now, if we don't get to all of your questions, we will forward them to our presenters later, and they can get back to you by email. So I think we have about 4 questions here. The first 3 are for Ken and Rob, and then we have one for Matthew at the end. So to Ken and Rob, what are my part search options? And can the system search different part classes at the attribute level of each specific part type? So 2-part question for you.
So that's a great question. So from a search standpoint, you have the ability to search based on any of the parametric data or information that we have available about the part. If we're analyzing a CAD model, we'll pick up things like the attribute tree and the design aspects. We can recognize mechanical features such as hole dimensions and hole sizes, hole shapes, tabs, cylinder padding, silhouettes of the part, and create similarity around those. So you can search along those lines. Of course, there's some performance characteristics. If you have, 16 million different parts, and there's 150 attributes for each part, and each part type has a different set of attributes, it makes it a little more complex from a user to narrow it down. However, the user interface is designed in a way that when I select a specific, say, part category or classification through the filtering mechanisms, the attribute other categories are automatically scrubbed out that aren't in the remaining data set. So it makes it very easy to drill down into the data. The search application as well has the ability to take even a CAD model that can be uploaded into the search and enables it to then go and index and use that CAD model and the shape of that CAD model to look for similar ones. So we see customers or end users who are creating CAD models or looking for a part, can't find it using normal search criteria and text search and things like that, will quickly mock up a part and then upload it before they actually turn that part into a new part number to decide or define or look for a part that may already exist that could be reused based on that. And they find that that significantly reduces, part search time from hours to just minutes. It only takes them a few minutes to mock up a part design for them. And what that does, though, is also reduces the number of new parts that get created in the system because they've been able to do that quick mock-up like they would if they couldn't find it. And instead of asking for a new part, they use that quick mock-up to actually look for a part in advance.
All right. Thanks, Rob.
And hopefully I answered all those question points.
You did. Rob, does it show associated parts and or parent-child relationships of the parts?
Yeah, I kind of showed a quick view of that in the demonstration as far as the parent-child relationships. What it will do is, using the AI application or the AI tool sets, use the shape to find similar parts in shape and size or hole layout dimensions. So if I'm looking for like a bracket that would fit a lug pattern, I can look for other brackets that have the same sort of hole layouts. It will show you the where used. So this particular part is being used in 6 different assemblies. And those assemblies, if you click up through that sort of parent-child relationship, you can actually see where those assemblies are being used in the upper classifications. And then, of course, inside of that view as well, at the assembly level, it'll tell you that there's 6 instances of like maybe this particular pin in this particular assembly, so you can kind of get an idea of how frequently is in this a similar part being used or the same part being used in the same assembly.
Thanks. We've got 2 more questions. So, Rob, a third question for you, and then the final one will go to Matthew. Can it work with multiple CAD formats, PLM systems, and ERP systems? And, the perennial question, what's the integration effort?
So the application, as Ken mentioned, we're agnostic when it comes to PLM and CAD. We handle over 30 different CAD types models, so SolidWorks and CATIA from Dassault Systèmes, but we also support NX and Creo and Pro-E and Inventor, Autodesk, AutoCAD, et cetera. From a PLM standpoint, we have what we call connectors. We have partners that create connectors for non-DS applications. So we can have connectors that would go into, Windchill or Teamcenter or, the 3D Experience platform and SolidWorks PDM Pro. And those connectors understand the data and the data format and how it's stored, and also how it's secured. We temporarily extract out the CAD model and get a read of all the attributes that are created in the design table of that PLM or PDM, and then bring that into the index. But we don't actually replicate any of that data into like a database where you lose that security standard. Then when a user goes to search for it, that information, they can click through back to the original source of record where they're using it in the standard workflow of that particular organization and their processes and policies.
How about ERP systems?
It's the same thing with ERP. So we have API integration to ERP, or you can do a data extract to even a CSV file. We can read that in. And then we have what we call consolidation rules tools that are built into the application that allows me to say, map, if there's a part number in the CAD model and a part number inside the ERP system, well, you can use that as a link point where then I can see the CAD model and I can get the ERP data. And that's how we do that sort of data merging to give you that holistic view. Configuration obviously depends on how much content and how it might be dealt with, but we can do a lot of that through the semantic processing built into the tool and some AI algorithms that are already pre-built.
Great. Thanks, Rob. Last question. We're going to direct this one to Matthew. Has Avancore managed this kind of project without Part 1? And if yes, how much time, workload savings did you measure?
Well, the answer is yes. Actually, that reminds me of good old times before we started to collaborate together with Dassault Systèmes, where we had large-scale standardization programs. I can tell you that it's not only a matter of time or workload we actually save. It's also just a matter of identifying potentials that we would not have been able to identify with the human brain at the end of the day. When we're talking about thousands of parts, you cannot ask a human brain to compare those parts. Just have a look at all of the CAD drawings and make sure that you are seeing the similarities and so on. This is just not feasible. So I would say that if I had to give a guess, we would at that time only be able to identify something like half of the potential that we are now able to identify with Exalit. When it comes to workload, it's even worse than that. I think we are just spending 25% of the time from a lead time perspective that we would have spent in a similar project a few years ago. So this is definitely a tremendous change for us and for our clients.
Great. Thank you, Matthew. That's all the time we're going to have. I just want to remind you again, if we didn't get to all your questions, we do collect them in an Excel spreadsheet. We'll be able to send the question and the contact info to the presenters, and they can get back to you by email. So once again, I want to thank Rob Donath, Matthew Modelund, and Ken Barrett for a great conversation today, and Dassault Systèmes for making this webinar possible. And again, be sure to go to the resource box. You can download today's presentation. You can get that URL to download the ebook, A Resilient Ecosystem of Qualified Component Suppliers. For Supply Chain Management Review and Peerless Media, I'm Bob Trebilcock.